When people hear the words quartz crisis, they picture Switzerland. They imagine alpine villages emptying, centuries of tradition collapsing under the weight of a battery-powered intruder from the east. That picture is wrong. Switzerland survived. The watch industry that actually died was the American one. By Christmas Day 1969, when the first quartz wristwatch goes on sale in a Tokyo department store, the largest American watch company has already declared bankruptcy. The second largest has been dead for over a decade. The third has just packed up and moved to Switzerland. Japan does not wound American watchmaking, it annihilates it. And the killing takes less than 10 years. For 500 years, a watch is a tiny mechanical engine. A coiled mainspring stores energy, a gear train transmits it. A balance wheel swinging back and forth against the tension of a hairspring parcels that energy out in measured beats. Every tick is the result of physical objects touching, wearing, drifting. Temperature changes the length of the hairspring. Gravity pulls differently depending on the position of the wrist. Even the best mechanical watches gain or lose seconds every day. Accuracy is expensive. It requires jeweled bearings, 17 at minimum for a railroad-grade pocket watch, to reduce friction at critical pivot points. It requires hand-adjusted hairsprings. It requires skilled labor, thousands of workers, factories covering tens of acres. The entire industrial logic of watchmaking, from the first mass-produced movements on the Charles River in Massachusetts to the last railroad chronometer calibrated in Lancaster, Pennsylvania, rests on a single assumption: that precision requires mechanical complexity, that gears and springs are the only way to measure time. That assumption holds for 5 centuries. It does not hold for 6. But before the crystal arrives, the American watch industry has to exist. And it begins on the banks of the Charles River in Waltham, Massachusetts, in 1854. Aaron Lufkin Dennison is a watchmaker who believes the techniques used to mass-produce clocks can be applied to pocket watches. His company, the Boston Watch Company, builds a factory in Waltham, Massachusetts, where the natural drop of the Charles River provides hydropower. The company will be renamed the American Watch Company and then the Waltham Watch Company, but the achievement remains the same. Waltham is the first company in the world to mass-produce complete watches under one roof, using standardized, machine-made, interchangeable parts. The Swiss are so alarmed by the quality of Waltham's output at the 1876 Philadelphia Centennial Exhibition that they send a representative, Jacques David, to study American methods. David returns home and warns his peers that Swiss watchmaking will be destroyed unless they adopt American-style mechanization. They do. In 1864, the National Watch Company is founded in Elgin, Illinois. It is renamed the Elgin National Watch Company a decade later. By the mid-1920s, Elgin's factory complex covers 21 acres and employs over 4,500 people, more than half of them women. It is the largest site dedicated to watchmaking in the world. Elgin produces roughly 60 million watches over its century-long run, peaking at over 1 million watches per year. The Hamilton Watch Company, founded in 1892 in Lancaster, Pennsylvania, builds legendary railroad pocket watches, models like the 992 and the 950B. After a fatal train collision in Kipton, Ohio, in 1891, caused by an engineer's watch stopping for 4 minutes, a Cleveland jeweler named Webb C. Ball is appointed chief time inspector and creates a set of standards: minimum 17 jewels tested in 5 positions, accuracy within 30 seconds per week. These standards shape precision watchmaking worldwide. By the turn of the 20th century, American watchmaking is an industrial powerhouse spread across 8 states: Waltham in Massachusetts, Elgin in Illinois, Hamilton in Pennsylvania, Waterbury in Connecticut, South Bend in Indiana, Gruen, Ball, and others in Ohio and New York, tens of thousands of workers, millions of watches per year. This is the world Kintaro Hattori is born into on November the 21st, 1860 in Kyobashi, Tokyo. Hattori is a merchant's son. At 11, he apprentices himself to a haberdashery. At 13, he visits a clock shop and decides that is his future. He reasons that now that trains are running in Tokyo, people will need to know the time. In 1881, at 21 years old, he opens Kei Hattori & Company, a watch and clock shop in central Tokyo. In 1892, he partners with engineer Tsuruhiko Yoshikawa to found the Seikosha factory. Seikosha means house of exquisite workmanship. In 1913, the factory produces the Laurel, Japan's first wristwatch. By the time Hattori dies on March 1, 1934, at 73, Seiko is Japan's largest watchmaker. 3 decades later, the man who will end American watchmaking is 22 years old and standing in the rubble of a bombed factory. Tsuneya Nakamura is born on March 8, 1923. He joins Daini Seikosha in Kamaido, Tokyo in 1944 at the tail end of World War II. In 1945, American bombs destroy the factory. The surviving staff and machines are evacuated to a fallback plant in Suwa, a small city in the mountainous Nagano prefecture. Nakamura, barely out of his teens, is sent with them. He arrives in a town surrounded by mountains, in a factory that has to be rebuilt from almost nothing. It is in Suwa that Nakamura begins the work that will define his life. The factory's output is behind the times. Seiko's designs are considered too derivative of European watches. Nakamura asks his superiors for resources to develop something modern. In 1956, at 33 years old, he produces the Seiko Marvel, an entirely new mechanical watch that modernizes the company's line and achieves immediate commercial success. The Marvel wins domestic chronometry contests. It leads to the Gyro Marvel, Japan's first automatic watch, using a winding system Nakamura helps develop called the Magic Lever. But the Marvel is a mechanical watch. It is still governed by gears and springs. It is still limited by the physics of oscillating metal. In 1958, Seiko builds a quartz clock for the Chubu Broadcasting Corporation in Nagoya. The clock is accurate. It is also the size of a filing cabinet. Nakamura looks at this filing cabinet and sees a wristwatch. The insight that will guide the rest of his career is forming a vibrating quartz crystal oscillating at thousands of cycles per second, can replace every mechanical component in a watch, the mainspring, the balance wheel, the escapement, the gear train. And once the crystal is small enough and cheap enough, accuracy stops being a luxury. It becomes a commodity. The 500-year assumption that precision requires mechanical complexity collapses. In 1959, Nakamura launches the 59A project at Suwa Seikosha. The name comes from the year. The mission is to develop a next-generation, high-accuracy, battery-operated timepiece. The first goal is not a wristwatch. It is a portable quartz chronometer. The filing cabinet must shrink before it can fit on a wrist. By 1963, the team produces the Crystal Chronometer QC951. It is a portable quartz clock about 20 centimeters tall, battery-operated, capable of running for a year on 2 D-cell batteries. Its daily error is 0.2 seconds. The 1958 clock stands over 2 meters tall. The QC951 stands 20 centimeters tall. It is not yet a wristwatch, but the direction is unmistakable. The 1964 Tokyo Olympics become the proving ground. Seiko is selected as official timekeeper. The company produces 36 models and 1,278 individual timing devices for the games. The QC951 is deployed. It is the first time in Olympic history that quartz timing is used across all major events. Seiko develops the world's first crystal oscillator digital stop clock, and it measures Abebe Bikila's marathon world record of 2 hours, 12 minutes, 11.2 seconds. The company also develops the first printing timer, which directly prints results as timing is completed. Seiko arrives at the Olympics an unknown Japanese manufacturer. It leaves as a global brand. While Seiko is shrinking crystals, American watchmakers are fighting a different war. Hamilton unveils the world's first electric watch in 1957, the Electric 500. It is battery-powered, but the timekeeping mechanism is still mechanical, a balance wheel regulated by electromagnetic impulses. It is notoriously unreliable. In 1960, Bulova releases the Accutron, the world's first electronic wristwatch. Its tuning fork movement, designed primarily by Swiss engineer Max Hetzel at Bulova's facilities, is a genuine leap forward, far more accurate than any mechanical watch of its era. Rolex is so threatened by the Accutron that the company engages in corporate espionage to monitor Bulova's progress. For a brief moment, American watchmaking looks like it might lead the electronic future. But the tuning fork is an incremental improvement. It replaces the balance wheel with a vibrating fork, but the principle is the same: a physical object oscillating at a fixed frequency. Seiko is pursuing something fundamentally different. In 1966, Suwa Seikosha develops a pocket watch-sized quartz prototype. In 1967, quartz wristwatch prototypes are entered in Switzerland's Neuchâtel Observatory competition. All 10 movements submitted by Suwa Seikosha to the 1964 competition are regulated personally by Nakamura. The crystal is almost small enough to wear. The fundamental constraint is now visible. The tuning fork vibrates at 360 cycles per second. The quartz crystal in Seiko's prototypes vibrates at 8,192 cycles per second. Higher frequency means finer division of time, which means greater accuracy. The tuning fork cannot compete with the crystal on physics. It is not a question of engineering talent. It is a question of which oscillator wins, and the crystal wins by a factor of more than 20. Meanwhile, the American watch industry is already DIYing, and the quartz revolution has not even started. Waltham, the company that invented industrial watchmaking in 1854, declares bankruptcy in 1949. The factory briefly reopens a few times to finish existing inventory, but every plan to restart the business fails. By 1957, the company exits the consumer watch business entirely and reorganizes into the Waltham Precision Instruments Company. Gruen sells off all of its assets in 1958. In 1964, Elgin relocates most manufacturing to a new plant in Blaney, South Carolina, a town so eager for the factory that it renames itself Elgin. It does not matter. In 1968, the Elgin National Watch Company, once the world's largest watchmaking operation, declares bankruptcy and discontinues all US manufacturing. The rights to the name are sold. Hamilton acquires the Swiss firm Buren and moves its operations to Switzerland in 1969. Benrus is sold by the early 1970s. The patient list tells the story. In 1955, the major American watch companies by volume are Elgin, Bulova, Benrus, Longines Wittnauer, Hamilton, Gruen, Waltham, and Timex. By 1970, the list is Bulova, Longines Wittnauer, and Timex. By 1980, only Timex remains. Bulova is purchased by Japan's Citizen Watch Company. American watchmaking does not decline. It vanishes. The causes stack up across decades. World War II diverts American watch factories to bomb timers, fuse production, and military instruments. When consumer production resumes around 1947, American companies are roughly a decade behind the Swiss in developing automatic movements. In the early 1950s, American manufacturers lobby Washington for higher tariffs on Swiss imports. The government imposes only modest ones. Swiss movements produced with cheaper labor and a devalued franc flood the American market. American factories age. The consolidation that might have saved the industry never happens. Switzerland has the state-backed ASUAG, formed in 1931 to protect its watch industry during the Great Depression. America has nothing equivalent. No government rescue, no mega merger, no coordinated response. Into this wreckage, on December 25, 1969, the Seiko Quartz Astron 35 SQ goes on sale in Tokyo. Shoji Hattori, president of Kei Hattori & Company, has made the decisive call. In late 1968, seeing the quartz development progress, he shuts down the parallel tuning fork watch project and tells Nakamura's team they have 1 year to deliver a commercial product. The name Astron is chosen to evoke the space age. Nakamura's team manages to produce 20 watches by early December, with production continuing through the launch. The movement, caliber 35 SQ, is 30 mm in diameter and 5.3 mm thick. The quartz crystal oscillates at 8,192 cycles per second. A hybrid integrated circuit divides the signal. A 6-pole stepper motor, its coil wound from 20 micrometer copper wire turned 20,000 times, rotates 60 degrees per electrical pulse, 1 pulse per second. The motor turns the hands. No mainspring, no balance wheel, no escapement, no gear train. A silver battery powers it for more than a year. Accuracy, plus or minus 5 seconds per month, plus or minus 1 minute per year. The best mechanical chronometers in the world cannot touch it. The watch is housed in an 18-karat yellow gold case, 36 millimeters in diameter, 11 millimeters thick. The price is 450,000 yen, roughly equivalent to a mid-sized Toyota. It is not cheap. It is not mass market. About 100 watches are sold by the end of 1969. A New York Times article on January 5, 1970, introduces the Astron to America under the headline, "Accuracy Stressed for Crystal Device in Japanese Watch." Seiko's marketing slogan is 7 words long. Someday, all watches will be made this way. They are right, and the decision that turns someday into now is not a product but a policy. Seiko publishes its quartz watch patents openly, deliberately accelerating global adoption of the technology. The tuning fork crystal oscillator, the integrated circuit architecture, the open stepper motor, Seiko makes the blueprints available to any manufacturer in the world. This is the moment the American watch industry's death becomes irreversible. Not because one Japanese company is selling luxury quartz watches in gold cases, because the technology to build a quartz watch is now free. Within a few years, quartz movements can be mass-produced for a fraction of the cost of a mechanical movement. Japanese firms Seiko, Citizen, and Casio scale production rapidly. American semiconductor companies smell opportunity. Texas Instruments, Fairchild Semiconductor, and National Semiconductor begin mass-producing cheap digital quartz watches. In 1972, Hamilton releases the Pulsar P1, the world's first digital LED wristwatch. The electronic circuitry is designed by Electrodata Incorporated in Texas. The integrated circuits come from RCA and Hewlett-Packard. It is a genuinely American innovation. But in 1973, Seiko releases the world's first 6-digit 06LC with a field effect liquid crystal display that runs for years on a single battery. The LED watch drains its battery in seconds of continuous display. The LCD watch stays on permanently. The American semiconductor companies, competing on price in a market they do not understand, lose interest. By 1978, Hong Kong overtakes the United States in electronic watch exports. The American chipmakers abandon the watch market entirely. By 1978, quartz watches overtake mechanical watches in global popularity. The numbers are staggering. Switzerland's share of the world watch market drops from approximately 50% around 1970 to roughly 10% by 1983. The number of Swiss watchmaking companies falls from 1,600 in 1970 to 600 by 1983. Employment in the Swiss watch industry plummets from 90,000 to 28,000. Towns in the Jura Mountains lose 8% of their populations between 1970 and 1980, an unprecedented decline not seen in the previous 100 years. But Switzerland survives. In 1983, the ASUAG and SSIH groups merge under the guidance of management consultant Nicholas Hayek, eventually forming the Swatch Group. Hayek's strategy is to unite the largest watch groups and produce an inexpensive, fashion-forward quartz watch using revolutionary plastic construction. The Swatch debuts in 1983. It saves the cash flow of the Swiss industry and funds the repositioning of mechanical watches as luxury goods. The Swiss pivot from competing on accuracy to competing on heritage, craftsmanship, and status. It works. Swiss watchmaking comes back from the brink. American watchmaking does not come back. There is no American Nicholas Hayek. There is no consolidation. There is no pivot. By the late 1960s, Timex has captured roughly half the American wristwatch market while still manufacturing domestically. It survives the quartz era by shifting production overseas. building 2 factories in the Philippines in the 1970s and later expanding to India and China. The company releases the Iron Man in 1986 and the Indiglo backlight in 1992, maintaining commercial relevance, but in 2008 the company restructures under a Dutch holding entity, Timex Group BV, and the American operation is renamed Timex Group USA. The other great names meet their ends. Hamilton is now a brand of the Swiss Swatch Group. Belova is a brand of Japan's Citizen Watch. Elgin's name is owned by MZ Berger, which manufactures watches in China and distributes them outside traditional watch dealerships. Waltham is a Swiss-owned brand producing watches with Swiss Soprod movements. The brands survive as logos on dials. The factories, the workers, the industrial base, the century of accumulated knowledge are gone. The geography of loss is specific. Elgin, Illinois, which once housed the world's largest watchmaking complex, loses its defining industry entirely. The factory clock tower is taken down in 1966. The factory is demolished. Waltham, Massachusetts, where Aaron Lufkin Dennison built the first mass-production watch factory on the Charles River in 1854, no longer makes watches. Lancaster, Pennsylvania, where Hamilton calibrated railroad chronometers to within 30 seconds per week, is out of the watch business. 8 states once had major watchmaking operations. None do now at any meaningful scale. The central idea reaches its realized form. Nakamura's lifetime project, shrinking the quartz crystal until accuracy becomes so cheap that craftsmanship no longer matters, achieves its endpoint. The movement that once filled a cabinet over 2 meters tall has been reduced by a factor of roughly 300,000 to fit inside a case 36 millimeters across. Today, 97% of the world's wristwatches are driven by quartz movements. The Seiko method is a world standard. A $20 quartz watch purchased at a drugstore keeps better time than a $5,000 mechanical chronometer adjusted by hand. The 5-century assumption that precision requires mechanical complexity is not merely challenged, it is disproven. The crystal did in 1 decade what gears and springs could not do in 500 years. It made accurate time free. Seiko Group Corporation is today a publicly traded company on the Tokyo Stock Exchange. Revenue in fiscal year 2024 is approximately 304.7 billion yen. The current chairman and chief executive officer is Shinji Hattori, a direct descendant of the founder. Seiko remains one of only 2 watch companies in the world, alongside Rolex, considered fully vertically integrated, capable of designing and manufacturing every component of a watch in-house. The company that Kintaro Hattori started as a repair shop in 1881 now operates across multiple continents, producing watches, clocks, electronic devices, and semiconductors. Tsuneya Nakamura becomes president of Seiko Epson, the corporate successor to Suwa Seikosha. He works on environmentally friendly watch technologies, including thermic and kinetic movements. He earned 6 stratospheric ozone protection awards from the United States Environmental Protection Agency for his work eliminating chlorofluorocarbons from Seiko Epson's manufacturing processes. He retires in 1994 at the age of 71, after 50 years at the company. In retirement, he sponsors foundations supporting education, science, and music in the Suwa community, the same mountain town where he arrived as a 22-year-old standing in the aftermath of a bombed factory. A funeral service is held on the 4th of February in Suwa, Nagano Prefecture. He is 95 years old. The American watch industry today exists mostly as a maintenance operation. Qualified watchmakers in the United States service Swiss imports. A handful of artisanal independents, RGM in Pennsylvania, Weiss in California, J. and Shapiro in Los Angeles, Avoirdupois in Manhattan, produce small numbers of watches with American-made movements. An Avoirdupois with a fully domestic movement retails for under $15,000. A J. and Shapiro will cost $40,000. These are beautiful objects. They are not an industry. The United States, which in 1876 so alarmed the Swiss with its factory output that Switzerland sent an emissary to study American methods, no longer produces watches at any meaningful volume. Nakamura's insight was not complicated. A vibrating crystal, properly miniaturized, could do what centuries of springs and gears could not. It did not require genius in the romantic sense. It required someone willing to spend a decade shrinking a filing cabinet into a wristwatch, one component at a time, in a factory in a mountain town that most of the world had never heard of. The 59A project, the QC 951, the Tokyo Olympics, the Neuchâtel competition, the Astron, each step smaller than the last, each step closer to the moment the crystal fit on a wrist and the mechanical watch became optional. For over a century, the United States was the birthplace of industrial watchmaking. Waltham invented mass production in 1854. Elgin built the world's largest watch factory and employed 4,500 people. Hamilton set the standard for railroad precision that shaped global timekeeping. American watch factories operated in 8 states, employed tens of thousands of workers, and produced millions of watches per year. The Swiss sent envoys to study American methods. The American system of interchangeable parts became the model for every watch factory on Earth. It took Japan 10 years to erase all of it. Not with an army, not with tariffs, not with espionage. With a crystal oscillating at 8,192 cycles per second, thinner than a fingernail, accurate to 5 seconds a month, and eventually cheap enough to put in every watch on Earth. Tsuneya Nakamura and the engineers of Suwa Seikosha did not set out to destroy the American watch industry. They set out to make a filing cabinet small enough to wear on a wrist. The destruction was a consequence, not a goal, and by the time anyone in Waltham or Elgin or Lancaster understood what was happening, there was nothing left to save.